What if I told you we could take one of the biggest technologies on the planet, artificial intelligence, and shrink it down to fit on the tip of your finger? Well, that's exactly what we're diving into today. We're exploring the absolutely fascinating world of tiny machine learning, or TinyML, where these massive AI brains get squeezed onto the tiniest computer chips imaginable. So let's get into it.
So let me ask you this. Have you ever asked your smart speaker to turn on a light and it just fails? It tells you it can't connect to the internet. It feels kind of ridiculous, right? I mean, why on earth does a simple command need to travel hundreds of miles to some data center and all the way back? That question, well, it gets to the very heart of our really big problem with how most AI works today.
You see, the problem is that most of the AI we use every day doesn't actually live in our devices. Nope, it lives up in the cloud. So let's unpack what that really means and why that trip to a distant server is such a big deal. Think about it. When you say, "Hey Siri" or "Alexa," what's really happening? Your voice gets recorded, then it's zipped across the internet to a giant server farm. There, a super powerful AI figures out what you said and then sends a command back. Your device is often just a fancy microphone and speaker with a real brain located far, far away. Now, this whole setup creates a few major headaches. First, there's that annoying delay or latency while your voice makes the round trip. Second, and this is a big one, your personal data, like your voice, is being sent to somebody else's server. That's a huge privacy concern. And of course, if your internet connection drops, your smart device suddenly becomes, well, not so smart. But what if there was a better way? What if we could just pull that giant AI brain out of the cloud and put it directly inside our devices? Well, that is the incredible promise of a field called TinyML. TinyML is basically the science of running these powerful machine learning models on super small, low-power hardware. We're talking about the tiny chips inside your watch, your headphones, maybe even your toaster one day. So instead of sending data out, all the thinking happens right there on the device. The whole goal here is to shift away from centralized intelligence. It's about making our everyday objects genuinely smart and independent, letting them make their own decisions without having to phone home to a server every few seconds. Okay, this all sounds pretty amazing, right? But it brings up one massive question. How in the world do you take a giant AI model and make it small enough to fit on a little microcontroller? Exactly. I mean, traditional AI models can be gigabytes in size, but the memory on these tiny chips is measured in kilobytes. It seems completely impossible, but it's not, and it's all thanks to some seriously clever optimization tricks. Let's see how they do it. Okay, first up, a technique called quantization. The best way to think about it is like this. A normal AI model uses super precise numbers for all its calculations. Let's call them 32-bit numbers. Quantization is basically like rounding those down to simpler 8-bit numbers. You lose a teensy bit of precision, but it turns out for most jobs, you don't even need it. And the result? The model's size can shrink by up to 4 times, just like that. Next up, we've got pruning. So a neural network has millions of connections, kind of like pathways in a brain, but not all of them are actually that important. Pruning is this brilliant process of identifying and just snipping away the weakest, least important connections. This makes the whole network way smaller and faster, and usually it doesn't even hurt its accuracy. And hey, don't just take my word for it. The results are incredible. Take a standard neural network designed to read handwritten numbers. It started out at over 5.5 megabytes, but by just switching to a smarter design, a convolutional neural network, the size plummeted to just 459 kilobytes. And get this, it actually performed better. Yep, a size reduction of more than 10 times. It's through this kind of smart engineering and optimization that you can take a powerful AI model and make it small enough to live right here, on a chip in your hand. So we know it's possible in theory, but what does this actually look like in the real world? Let's check out how TinyML is already changing the game and products you might actually use. Remember that smart speaker problem we talked about at the beginning? Well, TinyML totally solves it. Keyword spotting, the task of recognizing a wake word like Alexa, can run entirely on a tiny, low-power chip. A device can be trained to recognize a really small set of words, just the essentials like on and off. This means it can be always listening for those specific words using almost no power, and it never sends a single bit of audio to the cloud until it hears that one specific command. Okay, let's level up with a more complex example. On-device person recognition.
Think about a smart doorbell or a security camera. This can run completely on a small computer like a Raspberry Pi.
And the process is actually pretty simple. The camera grabs a frame, the device itself figures out if there's a face in the picture, and then it recognizes who it is. And here is the most important part. All of this happens locally. The video of your front door never ever leaves your house. That's a massive win for privacy. So these examples are really cool, but the implications of TinyML are so much bigger. This is really about redefining our entire relationship with technology. Let's just quickly recap the benefits here. When processing happens locally, responses are instant, no more lag. Keeping your data on your device massively improves your privacy. Your gadgets will actually work when the Wi-Fi is down. And because it uses so little energy, devices can have always-on smart features that don't drain the battery in an hour. That's why so many experts are calling TinyML the next frontier for the Internet of Things. It really is the key to unlocking a future where intelligence is just embedded everywhere, in billions of devices all around us, making our world more responsive, more helpful, and a whole lot more secure. Which leaves us with a final and pretty mind-bending question. If we can give a tiny, efficient brain to literally any object, from our coffee mugs to our running shoes, what is the very first thing we should teach them? The possibilities are just endless. Thanks for joining us.